Hi again, everybody. In this video, I just want to do a short video introducing the idea of an equation. So we're going to come back and do a lot more with equations in a few videos from now, but I just want to introduce it here. So what we're going to do particularly is we're going to identify solutions in equations. So again, we're just going to start introducing this algebra stuff early on, which is good because it gives you more time in class to work with it, because you're going to be working with algebra in your next course a lot. No matter where you go, there's going to be some sort of variable there or symbols used. So it's good to start working with this algebra early in class. And then also, hopefully, it brings in a little bit more challenge rather than just always doing adding whole numbers or subtracting whole numbers and things like that. So kind of bringing in some of the algebra early on. So the first thing I want to notice the difference here between expression versus an equation. And I think it's easiest to see with an example. So an expression could be something like 2x plus 4, whereas an equation is 2x equals 4. So what you want to notice is that in both cases, they can have variables, they can have numbers, they can have grouping symbols, they can have operations. So both can have variables, numbers, operations, so things like adding, subtracting, multiplying, dividing, and grouping symbols. But equations have equal signs. Okay. Also, we solve equations to find the specific solution or solutions, whereas we simplify expressions. Okay? And we can also evaluate expressions for different numbers too. So we're not locked into like one specific solution for expressions. We can plug in all different numbers and simplify them to get the result there as well. So let's talk about a few more definitions here. So a solution to an equation is the value or values that make the equation true. So for expressions, we can evaluate. We did this in the last video for all different numbers. Whatever we want to plug in, we can do that. But for equations, if we're trying to solve, we want the answer that actually makes the equation true, that makes it make sense. And solving the equation is the act of finding the solution. So let's do an example. Is x equals 4 a solution to the equation 5x plus 6 equals 1? So how do you determine this? What you need to do is you're going to plug the answer or value into the equation and simplify. If the statement is true, then you have a solution. If the statement is false, then you do not have a solution. So let's do the example here. So what we're going to do is we're going to take this value of 4 and we're going to replace it in the x. And we're going to see what happens. So I'm going to do this up above here so we can kind of see it. So I have 5 and I'm plugging in 4 just like we did with evaluating. So we're really evaluating here. Plugging in that 4 plus 6 equals 1. And then I'm going to simplify using order of operations. Well, 5 times 4 is 20. And 20 plus 6 is 26. So now I look at my answer. 26 equals 1. Is that true or is that false? Well, obviously that is false, right? That is not true. So in this case, if our solution is false, then x equals 4 is not a solution. So to answer this question, do we have a solution? We just go ahead and we plug it in and see what our result is going to be. Let's do one more example here. So here, determine which members in the set of 40 and 20 are solutions of the equation 2n minus 30 equals 10. Now here we're using n for our variable, which is totally fine. It doesn't matter what your variable is. And our set is just a group of numbers. So we're going to try both 40 and 20 and see if any of them work. Maybe they'll both work. Maybe only one will work. Maybe none will work. So we'll have to see what happens. So I'm going to take that 2n minus 30 equals 10. And I'm going to try n equals 40 first. So what I'm going to do is I'm going to replace my n with 40. And I'm going to see what happens. And you have to follow order of operations here. So 2 times 40 is going to be 80. 80 minus 30 is 50. And obviously 50 is not 10. This is false. So since this is false, 40 is not a solution, this particular equation. Let's try n equals 20. So I'll go back to my equation. I'm going to replace the n with 20 this time. Let's see, 2 times 20 is 40. 40 minus 30 is 10, and 10 does equal 10. This is true. So 20 is a solution to the equation. So again, just a little introduction here to equations, and also noticing the difference. So with expressions, notice that in the last examples, you can really pick any number, pretty much any number you want to plug in, and you'll be able to simplify to get an answer there, right? When you have an equation, there are specific values that work when you plug them in. So with an expression, you can almost plug in anything you want. Again, there are some exceptions there, but in general, you can plug in almost anything you want with expressions, and you can always simplify to get a result. With equations, though, some things when you plug in are true, some things when you plug in are false. So you want only the values for equations that make them true. Those are what we call solutions. And that's where we're going to be spending a lot of our time in class later on, is how do we find these solutions without just guessing, right? So here on a pretty simple equation, we can maybe guess pretty easily. But if you have harder equations, how can you find these solutions without just guessing and plugging things in to see what works? And we'll get to that in a few videos from now.